So hello everybody, my name is Heikki Kortti. I'm here talking to you today about something that's related to the previous talk we saw on fuzzing. I work at a company that does fuzzers for various network protocols and file formats, including also wireless stuff. So I found the previous talk in this room very interesting from a professional standpoint. I have to, in the beginning, say a few practical things. If you have any questions, it's okay to interrupt me at any time. I'm a nice guy, so I won't shoot you if you shout obscenities from the audience or curse at me for saying some improper things. It's also okay to stay here or go outside after the end to discuss some matters if you want to discuss some things privately with me. There's also a nice page in the wiki for DeepSec for each of the talks. So if you have any questions or ideas that come to your mind during the presentation, criticism, comments, questions, feel free to go in and even edit the wiki page for my presentation and add your questions or comments there. I'd like that. So without further ado, I'll start discussing some of the topics that I have on the agenda today. So we've seen a lot of talks about vulnerabilities, about ways to exploit flaws in software, but my talk concentrates on a more specifically input-oriented approach. So I'll be just focusing mostly on how to design effective inputs that traverse a software system and make trigger bugs or vulnerabilities in the system. I won't be talking about ways to do advanced exploitation or take advantage of the flaws that are found. I'll more be talking about what kind of inputs we can create that trigger the vulnerabilities that might reside in any software. So we've coined the term destructive data as this kind of fancy word for designing inputs that make software fail in various unexpected ways. I like to think of this as kind of like cathartic testing. So if you know the Greek term catharsis, it's a mindset where you think that through destruction you actually can improve things. So it's kind of constructive destruction if you allow a paradox. So when we are discussing destructive data and ways to design destructive data, you must really think like you were a malicious input going through a system, traversing all of the various components in a system, going through the parsing stages, all the way up to output generation stage. You always have to think specifically about the interface that you are approaching. So if you are trying to break a network protocol, it's a little bit different from breaking a file format implementation. So you must always still think how your inputs that you are creating will actually go through the software and what kind of effects, what kind of code it might be passing along the way. So typically the inputs that we create, they are captured by a parser maybe. The parser passes it on to deeper layers. The data is transformed, it's processed in various ways, and finally it reaches some inner location in the code. You should always also think about what kind of possibly underlying flaws are there in the code. So you might think of buffer overflow conditions, but you might also think of state machine problems, null pointers, what have you. So you should always consider if you make a different kind of input, what kind of flaws it can actually trigger. The most important thing when designing destructive data is to really think malicious. I'm sure this is no problem for many of you, but some people think of still approaching software and testing software as performing some kind of valid interactions with the software. But the main thing is to forget all about that and start thinking really in a malicious way. Start doing everything that is not expected by the software, breaking its assumptions in all levels, so to speak. So if you are looking at the network protocol, for instance, if there are type fields, length fields, different kind of values, header versus payload situations, or there are state machines defined in the protocol specification, even things like how is logging done, how is debugging done for a particular input, those are always very important aspects to consider when testing something. So you might think of what are the effects of parsing a particular length field, what kind of interactions will the software do after it has read in a particular length value from an incoming message, or if you can somehow tweak the header versus the payload, so make the header look like there would be something else expected in the payload, and so on. So you should consider all of these different kind of sort of basic primary elements in protocols and file formats. Most of the time it helps to know really if your target that you are attacking, whether it's written in C or C++, that's kind of an obvious thing. But it's not always strictly necessary. You can also start creating malicious inputs and then later on find out what are the conditions that are being triggered. So actually when designing the malicious inputs and when injecting them into your target system, you might accidentally find out that the target is written in a particular language because of the types of vulnerabilities that you are unveiling. So you might approach, if you know the internals of the system that you are testing, that always helps. But you can also approach the tested implementation as a completely black box without any prior knowledge, except from the fact that it has a particular interface that you can use to start injecting your tests to. Now, a couple of terminology issues. When we think of destructive data, the primary term that we like to use is called anomaly. We think it's a good term because it captures kind of the idea behind what we are doing. So it's destructive data is a good sort of fancy word, but anomaly is more, it captures the idea of what we are doing. It's basically any kind of malformed input. It doesn't have to be just some kind of fuzzed value field. It can be like really unexpected things like reordering a sequence of messages, for instance. If you think of a complex protocol message sequence like TLS or BGP, for instance, you might reorder the messages in that, reorder the expected order of messages in that message sequence. So you might start finding really interesting things just doing this kind of very simple approach. Or do things like cut a file or a message abruptly in the middle. You make a valid file or valid message, and then you suddenly cut it from a location somewhere within. Or doing things like deep recursion for a file format that allows that. So it doesn't have to be that you are fuzzing a single field or single element. You should think of anomalies in a wider way. You should always think of sequences as well, sort of substructures that you can also undermine, and think of also combining things, not just anomalizing one field, but anomalizing multiple things in a message at the same time, sort of going crazy with anything you have at your disposal. Now, when we talk about the destructive data and anomalies, the inputs that you use to attack software, vulnerability is the underlying condition. It's the bug, it's the flaw, programming error, or some vendors call it just issue, that the destructive data is actually able to trigger. The anomalies that we create and send to a piece of software, those trigger the underlying programming errors that may exist in the software. Symptoms can vary a lot, as I'm sure you've all seen in your practical work. We might see crashes, we might see exploitable conditions. You might be able to exploit a particular, let's say a buffer overflow or a similar kind of issue. But you might also see temporary slowdown slowdowns of the system that you are testing. You might see things like memory, CPU consumption, resource problems, errors in actually log file handling. For instance, things like portions of the log files disappearing as a result of the data that you are sending. Also, what's called like second-order vulnerabilities, meaning that this data that you send ends up in another location, like let's say SQL backend, and when somebody is using a log analysis program, it might actually trigger some within that log analysis program. So sometimes the symptoms are very surprising. Like I have to say that I'm always surprised by the different kind of symptoms that very simple malicious data can cause in software. So we've seen some very amazing things happen in some devices, as I'm sure you have seen during your career or work. So a lot of the time the underlying errors are the simple vulnerabilities that we have heard about in most other presentations or through your own research. Basic buffer overflows, pointer arithmetic problems, different kind of type conversion issues, memory management problems, memory allocations, or not freeing elements that have been reserved. Some kind of input sanitization problems. There might be no filtering done for incoming data, no sort of sanity checking for the inputs that are coming in. Or if there is some debugging information output to the log files, there might be a problem with sanitizing the destructive data that is actually then moved to the all the way to the log. So input sanitization, yes, but also output sanitization. You don't want your log files getting filled up with ANSI escape sequences, for instance. So then when we discuss exploitation, it's yet another view of the same sort of problem. So destructive data looks at ways to trigger vulnerabilities, but exploitation is then another way of taking advantage of the vulnerabilities that are found. So I'm actually in this presentation not discussing the vulnerabilities and the exploitation of vulnerabilities in any practical detail. I'll actually be connecting some of the anomaly categories that we'll see to some representative programming flaws and giving you a couple of case examples of what kind of real-life errors can be found with very simple destructive data. So there's two basic ways of looking into the same underlying condition. You might think of the situation from the point of view of the destructive data, from the point of view of the inputs themselves, or you can concentrate on the underlying flaws. Many times if you have a solid programming background, you might more consider about the vulnerabilities and ways to exploit them. But if you think of the view from a black box testing standpoint, it's more concerned with how you can actually trigger the flaws. You don't care about the flaws themselves that much. You care about the ability to create representative inputs that will trigger certain categories of flaws. So the basic problem is really like when you are designing anomalies and designing these kind of fuzzing tests, what are the flaws that typically can be reached by particular kinds of inputs? So you might create some very advanced and fancy attacks, but you might not always know what kind of programming error is being triggered by these attacks. There's really an easy solution to this. You can connect your anomaly definitions and ideas about the ways to create destructive data with common categories of vulnerabilities. And that's a rather simple insight, but it goes a long way into actually documenting what you are doing with your destructive data and connecting it, possibly providing some information to the developers, providing some information to third parties about what are the errors that you are actually triggering. There's a thesis work from a colleague of mine who is actually focusing on just this ability to connect the destructive data with or assess the quality of destructive data by connecting it to the different types of vulnerabilities that it can trigger. One system that I'm sure you all are familiar with already is the common weakness enumeration.